Welcome back, Twitch. We're here live at the AWS Santa Clara Summit. We're joined by some friends here from the Redshift team. There were a lot of really exciting announcements in the keynote about Redshift, and I want to get everybody to introduce themselves, and then we'll start talking about some Redshift. Does it sound good to you?
Yeah, sure thing. So my name is Ayush Shen, and I'm a Senior Product Marketing Manager at AWS. And I'll let Michael introduce you.
And I'm Michalis. I'm Director of Engineering for Redshift. Thank you for having us.
Thanks for being here. I'm Robert. I am an evangelist, and I work with AM.
Yeah, I'm AM. I'm also an evangelist here at AWS. Now, we're going to talk about Redshift, and there are a lot of things announced. Werner talked about today during the keynote, but if you missed the keynote, let's do some highlights real quick. What do you think? Some of the things that stuck out to me, obviously, 10x improvement, right? That's pretty amazing. What about you, Robert? What else was there in the keynote?
Well, I think there's the number of customers on Redshift has seen steady growth, and that's really impressive because it seems like a service that is just constantly adding new features at a steady clip, and they're very thoughtful features. So maybe you guys can take us through some of those announcements and what's your take on them?
Sure. So Redshift has been the first cloud data warehouse. It's the database that can actually handle petabytes of data, and given the improvements that we have done the last few years, it can now handle exabyte scale data. And the very exciting announcement that Werner did this morning is that we can the service can actually scale in any dimension, not just the data itself, but also in terms of users. So he announced the concurrency scaling that can actually allow us to use additional clusters whenever they are needed in order to accommodate peak usage during the working hours. Also, the service itself, being a cloud data warehouse, is also very flexible in terms of how much hardware do you want to use, how much compute, how much storage do you want to use. For that reason, it's not only the most performant data warehouse in the cloud, it's also the most cost efficient. So this resonates very well with customers, and that's how we see the steady increase in the customer adoption that we see now.
Yeah, and what particularly catches my attention, Ayush, you and I were talking about this before, that Redshift processes over 2 exabytes of data per day. Is that right?
Yeah, that's absolutely right. And if you imagine how much that data is, if in today's speeds of 25 megabits per second or whatever you get with your ISP, it would take you 1,000 years to actually download all of that data. So that's a huge amount of data that customers are processing.
I'll wait.
Ain't nobody got time for that.
No? Are you sure?
Yeah, I didn't believe you, so I did some research. And
you had to but verify.
Well, that's such a crazy number, and it's one of those numbers that blows your mind, right? 2 exabytes of data. That's not a number that you hear day to day. And just to help you visualize what that number means, in 1986, there was just 2 exabytes of data.
That's
it.
Everywhere.
That's it. There was just 2 exabytes of data.
Right.
As recently as 2004, every month we had about 1 exabyte of data worth of traffic across the global internet.
That's pretty awesome.
So that to me, that you're amazing. Doing 2 exabytes of data per day, just really hammers home the scale at which we're operating here.
I do want to take a step back real quick. We've got your attention with the performance of Redshift, but data warehouse, Redshift, these might be terms that some of our viewers have never heard, never touched. Why would I use Redshift versus a traditional relational database, for example?
Right. So people have been using the first database that they come in touch with is a transactional database that they use to register their sales, something that very small data additions in a very high frequency, right?
Right.
So these databases are very good for this particular workload. You buy an item, you add a record in your database as fast as you can, and you need to do that 1 million or 1 billion times per minute, right?
Right.
So, but these databases, they're not appropriate in order to, when it comes to scanning petabytes or even high hundreds of terabytes, they cannot handle that type of load, right? They're not optimized for that type of queries.
Right.
So the transactional databases are complemented by the Redshift database or data warehouses in general, so that they can actually run analytical queries or machine learning queries over petabytes and these days also exabytes of data.
That makes total sense. Sure. Yeah.
Right.
It's more analytic-based workloads instead of transactional-based workloads, right?
That's right.
That's the general gist of it.
That's where you accumulate your transactions that are happening on a daily basis and run analytical queries in order to predict how many items you need to order in order to have an efficient supply and demand chain, for instance.
Yeah.
And
So I
can
do
you
want to
tell-
get back
oh,
to
sure.
your
Yeah.
question though. Why are people using Redshift versus these traditional data warehouses
Yeah,
that existed
absolutely.
on premises? And so there's basically three things that are happening. Customers are seeking out a data warehouse solution that has high performance for read and write queries, a data warehouse that can scale, and also a data warehouse that's easy to use. And so if you imagine a world in the traditional data warehouses, these data warehouses were extremely rigid in their architecture, which meant that if you had to scale them, you had to deploy more hardware, you had to do an expensive upgrade operation, and it would take you days and thousands and millions of dollars to do that. Now you can just do it in a couple of hours and even minutes, right? So
Right.
that gives you extreme scalability. It's also really easy to use because Redshift administers the day-to-day tasks for you automatically. It manages resources for you. It performs the common administration operations and also automatically deploys capacity, as Mihalis just mentioned, with concurrency scaling when your queries start to queue. And so with all that automation, Redshift becomes very easy to use compared to a traditional data warehouse. So, ever since we have launched, Redshift has been 10x faster and 1/10 the cost of traditional data warehouse. And that's exactly why more than 10,000 customers have adopted Redshift.
Yeah.
That makes sense, yeah.
10x faster. Now that's not chump change. That's
No.
not you're just rooting through the couch for spare change anymore. What kinds of engineering feats did you have to orchestrate to pull off this kind of order magnitude improvement in terms of perf? And where does that come from? Take us through that.
Right. So we're actually using a unique characteristic of cloud data warehouses in that you can actually see and observe the behavior of the workload of every customer, and you can actually employ machine learning in order to figure out which queries are short, which queries are long, and schedule them accordingly in order to maximize the throughput of the database, right? So what we have done, and keep in mind, by the way, that we have the entire spectrum of customers. We have very large customers that are executing very heavy queries against a lot of data on a daily basis, and we also have much smaller customers that are cost conscious and they're dealing with less data and shorter queries. And machine learning allows us to actually accommodate all these use cases and customize how we're scheduling the queries for each customer individually. So for that matter, what we're doing is that we're recognizing what a short query is for every customer, and we bypass the queue, the incoming queue, in order to allow them to execute as fast as they can and get in and out of the system very quickly, which is a common theme in queuing theory. And for that, you're also helping the interactive dashboards, right? Because these are the queries that need to come in and out of the system very quickly in a few seconds.
And so that's where that 2 exabyte number, I want to come back to that number for a sec. That's where that number is so important. It's not just a vanity metric that we are tracking and feeling good about, but because we are processing that much of data per day, it actually helps us train our machine learning models way better than anyone else can.
Yeah.
And it also helps us learn about optimization patterns, because of which we have shipped over 200 features and enhancements over the last 2 years.
Yeah, that sounds exciting. So does the customer need to do anything to take advantage of these improvements that we've been talking about?
Nope. This was completely transparent. We just announced it, and even some of the customers were sending us messages. It's a lot faster. What
Yeah.
happened?
As a lazy person, I like the sound of that.
That's my favorite kind of update.
yeah,
right?
yeah. You just
That's
get it
right.
for free.
Yeah.
It
That's
works.
Yeah.
No
Yep.
configuration.
That's
So
right.
we talked about concurrency scaling today too in the keynote. Can you explain more about what that is and maybe when a customer might actually need to utilize that?
Right. So as you can imagine, any business, it has peak hours and non-peak hours, right? So as Jeff Barr said in his blog post, customers today, what they need to do sometimes is either provision for peak traffic in order to provide consistent query performance, or optimize for off-peak traffic, in which case during peak hours some queries will have to wait in the queue, right?
Right.
So what we're doing here with concurrency scaling is that we allow the users to actually attach additional clusters to their configuration within 3 seconds in order to utilize additional compute capabilities, accommodate the burst traffic for as long as it occurs, and then we take the clusters back when the traffic is down, right?
Right.
And the interesting thing about this is that, yet again, you don't really have to do anything. It's just a checkbox that says enable, and then it just happens.
Maybe we should have put a feature in there that makes the customers check, yes, I want faster performance and lower costs.
That's right.
Why don't we actually see that in action?
Yeah. Oh, great suggestion.
Cool. So we have a little animation here on the screen, and so what you can see here is what Mihalis just talked about a few seconds ago.
Yeah, I think I'll have to switch over to your display here. We should see it here come up in just a second.
Cool.
So we're not.
See.
We don't see the slide on the monitor.
There we go.
Oh, there you go.
We're good.
There we go.
All right.
All good? Yeah, so what you basically see here is two queues, and there's a machine learning algorithm that's actually predicting the runtime of your queries. And so if your query is a short query, Redshift is assigning it to a dedicated short query acceleration queue, and if it's not, it's assigning it to a default queue. Now what you'll see in this animation is as queries start to come in, some of them might start to queue because of the load that's coming in. Right? So what we have now done is enabled concurrency scaling on your default queue. And so Redshift will automatically start a new queue that would take all those queries and prevent queuing. And in this case, there's not just one queue, but actually two queues that are being deployed dynamically, and the queries are just being routed to the best queue that has availability. And because of this, customers can now get consistently fast performance, even when their load is varying over the course of the day.
So during a beta version that we did, so this feature is GAing today, of course, as Werner said, but we have done beta versions, a beta track for customers, and we saw that they were able to eliminate 97% of their queuing time. So no matter how many users you're actually putting on the system, nobody's waiting in line.
Wow. That's incredible.
Yeah.
There's one more cool thing about this feature. So with every day that your Redshift cluster is running, you get 1 hour of free concurrency scaling credits. And you can accumulate them over the course of a month, which means that if on a certain day in a month you get all this load and concurrency scaling activates on your cluster, you won't get charged right away. You can use those credits towards that extra cost, and most of the customers will therefore not actually see any cost at all from using concurrency scaling. And that's a huge advantage for customers when they use the elasticity of cloud resources, but don't actually have to pay for them.
Is that visible in the dashboard? Can you see that in the console?
That's right. So you can monitor this in your CloudTrail metrics, and you can also enable concurrency scaling in the workload management queue.
Excellent.
So also in terms of how we're charging for this feature,
Yes.
keep in mind that we don't charge for the duration that an additional cluster is attached to your configuration. We just charge for as long as queries are actually running on the additional clusters.
Got it.
So there is a cool-off period, of course, where we observe that the queuing there is no more queuing in the system. You don't pay for this period. We just take the cluster back whenever you don't need it anymore, and then we engage it again when you need it.
That's a great way to pay for it.
Right.
I'd say, yeah. So I just wanted to kind of get a little bit further too. We talked about the data warehousing, why I would use it. Redshift has a way of storing data. It's column-based, right? Mm-hmm. And I think that's a challenge mentally for a lot of people joining this world for the first time. Kailas, do you have any advice on anybody who's trying to understand that model? Why is it shifted to a column model instead of traditional row-based?
Correct. Yes, the reason is, as I mentioned before, it depends on the access patterns, right? So if you're trying to register another sale, for example.
Can you move your microphone up a little bit?
There. It's good. If you're trying to add another row in your database, all you care about is actually inserting a new row.
Right.
With all the attributes. I sold this product on this day for that much, and that's the location, right? So this is one row that you're trying to insert into the database, and that's the fastest way to actually do that.
Sure.
On the other hand, when you're doing analytics, what you really care about is reading massive amounts of data as quickly as possible.
Right.
So that's why you go columnar, because if you're going to see the average demand of a particular item in a region, you need to read about millions or billions of rows as quickly as you can.
Right.
And not necessarily all the columns, just the ones that really matter, right? So in that case, what you need to do is store them columnar so that you can read, fetch the data in memory and go through them as quickly as you can. And these days we're also, taking advantage of hardware innovations so that we can read as many rows as possible at the same time. We'll go at a very low level of that. So that's vital. Yes.
Yeah.
There's actually one more related thing that I wanted to touch upon here.
Sure.
With most data warehouses, customers have the limitation of first loading data into their data warehouse, and then they're able to analyze it, right?
Right.
So we just talked about the columnar architecture, but that still has the limitation of loading data. Redshift is the only cloud data warehouse that actually enables you to analyze petabytes of data in your data warehouse and exabytes of data in your Amazon S3 data lake without having to move data around. So what you can do is join data, which is loaded already in your data warehouse, with data that is in your data lake in open formats like Parquet and ORC in the same query with Redshift Spectrum feature. And that's a huge advantage, again, for customers, because they don't now have to wait to load data first and then analyze it. They can just analyze it in near real time.
It sounds like Redshift kind of sits at the center of an analytics platform that you might build. Can you talk more about that, like the part? You started with the data lake, right, and the data warehouse. What are some differentiations between those two, and how does Redshift tie it together? What types of things can I do with Redshift around
So Amazon, provides an analytics platform, meaning that we have a bunch of services that you can use for different purposes, right?
Right.
So we have EMR, for example, that is closer to the Hadoop world and serves very well batch processing. We have, and of course you can use Spark on it and other tools.
Right.
We have SageMaker that you can also read data from the data lake, meaning S3 really. That's where we store open file format data in Parquet, ORC, and so on. So there are a collection of tools that can actually act on the same data, right? So the last thing that we're going to do is ask the customers to move data around.
Of course.
So what happens is that Redshift has a built-in support for data lake, meaning that it can transparently access data in the data lake as Parquet files, as well as ingested data in Redshift, and you can join the two without needing to ingest the data or any unnecessary data transfer. And of course, the benefit there is dual, right? Not just Redshift accessing the data in the data lake, but can also publish data into the data lake so that other services can utilize the data for their own purposes.
Right.
So that's the ecosystem that is really important for the customers and to avoid data movement across services.
So that gives you the flexibility to get the power of big data processing or the power of local disk with a data warehouse and the power of ad hoc analysis with services like Athena, all within the same platform, without needing to individually load data into each of these services. All of your data stays in the Amazon S3 data lake at all times.
Right. Right. And moving data is one of the biggest hindrances to actually getting to work with your data. Right?
Once you move data, they are out of sync. You just see a snapshot, it's not live anymore.
Yeah. And it's never valuable, right? It's never a valuable action to have to move data. So that's great. I think that's really great. In the last minute or so, is there anything you want to leave the viewers with about the announcements today? Any more summary or anything you'd like to share?
There is a lot more coming.
Oh, that's always good news.
That's right.
There's always more coming, right? But there's a lot more coming.
A lot.
I do want to make sure that we tell our viewers where to find more information. So you should look at the AWS news blog where we just posted about concurrency scaling. That's a really good way to understand what the feature does. Also visit the Redshift website, just aws.amazon.com/Redshift, where you can find more details about all the new features that we've been releasing. And then finally, try Redshift if you haven't already. It's very easy to try. You can spin up your own data warehouse in just a matter of minutes. You can also use our trial experience that we recently launched with our partner, Mode Analytics, which helps you load data, create a Redshift cluster with preloaded data so that you don't have to jump through hoops and get a Redshift cluster directly set up.
Yeah, nice. And that link, you don't need to memorize that. You should see Twitch viewers, you should all see a click-through action link on the Twitch stream. That'll take you to more information about Redshift.
Thank you so much for joining us. Stick around, we've got more coming for you.
Thank you.
Thank you.